Hello, my name is Nikki, and I currently work at the DataX lab at Berkeley, and I'll be covering the NLP module for this class. So first, let's dive into what exactly NLP is, and it stands for Natural Language Processing, and it's a subfield of data science that focuses on analyzing language and processing text and extracting meaning from that text. And there's a lot of multiple uses for, including sentiment analysis, text classification, natural language generation, automatic captioning, machine translation, and more. So how we'll be covering NLP in this class is breaking it down into three sections. So the first section that we'll be diving into today is text processing. And this involves cleaning up the text and making it consistent so that we can increase prediction accuracy later on. Then we'll move into feature engineering and text representation, which is where we'll learn how to extract information from the text. And then we'll go into learning models, which is where we'll learn models such as SVC, multinomial naive Bayes, and that's where we'll first train the data, and then we'll be able to use these models to classify unseen data. So diving into the first model, text processing. So the first section we'll cover is how to clean text using the built-in string methods. And first, let's talk about the importance of cleaning. So when you're given a raw set of data, it'll have different syntax, and you'll need to make the format more consistent in order to increase accuracy. So first of all, we need to look through the data to see exactly what to clean, because based on the data set you're given, you'll need to clean different things. So things that you need to look out for first is capitalization, and second thing is different punctuation conventions. So this example where you need to look through data, because if you have addresses, right, you might be looking at the streets and seeing if they put a period at the end of it or not. See if they omitted words, if they used white space, or if they have different abbreviation conventions. So the methods that are useful for cleaning involve string slicing. So this is where we can cut out certain parts of the words. Str.lower is useful for the capitalization aspect and making everything lowercase. String.replace is useful when you want to replace a certain word with another word. So for example, over here, if we want to say we don't want the white space, we can replace all of DE space WITT with DE WITT. And another one you can use is split and strip. And let's go into cleaning text using another method. So instead of using built-in strings, what we'll be using is regular expressions, or regex. And first, let's talk about what regular expressions are. And what it really allows us to do is to create general patterns for strings. So one use of it is using it for literals. So it can literally just replace and will match any character with the character A in the string. And there's also special characters in regular expressions. So for example, the period character matches any character that contains the character after the period. So example, if you want to use a function show regex match on call me at number, and you put in r.all, it'll match call, since all is within the word call. The backslash character signals to interpret the next character literally, so it will only match the character after the backslash, and compared to .all also matched call. And the period character also matches any patterns that may vary. So for example, if you do to match a phone number, you could do dot dot dash dot 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 dash dot 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 dot, and it'll match this phone number when you put that in. So other features that are useful is negating characters. If you want to match everything except for what's after the that character, that's what you use. And square brackets are also useful, and it matches something that you kind of don't know about a string that you're looking for. So for example, if you matched square bracket D, B, and then AN, it matches Dan and Ban, and you can add more characters here. So if it was DBC, it would also match can on top of Dan and Ban. And you can also use a range of characters for square brackets. And so for example, if you want to use the letters capital letters A through Z, you would use A through Z and that would match with and, ban, can, all the way up to Zan. And you can use this with numerical formats as well. So for another way to match a phone number would be using this. So 0-9 means a number from 1 to 9, and another number from 0 to 9, number from 0 to 9. So moving on to how regular expression methods are useful for text processing. Um, so what you would do is you would put in the regular expression patterns that we learned into the place that says pattern, and then you would use these methods for text processing. So example, re.search and re.findAll finds all the parts of the text that has a certain pattern that you put in. re.sub substitutes the pattern and with the replacement in the provided string. And re.split splits input string each time the regular expression pattern appears. So moving on to stemming and lemmatization. Stemming is the process of reducing inflections in words to their root form, such as mapping a group of words to the same stem, even if the stem itself is not a valid word in the language. So playing goes plays, played, all get reduced to the word play, am, are, is, to be. And the key part of stemming, one thing to notice, and it's different from lemmatization, is that the stem itself might not be a valid word in the language. And how you perform stemming is first you import a stemmer, and there's a lot of different stemmers, but for this class we'll use Porter stemmer. And then you iterate through data and iterate through each word in a data point and take each word and step it using porter.stemWord and then rejoin the words. And the reason you have to iterate through data and extract each word and then rejoin it again is because the stemmer only works on a per word basis and it'll just return the original sentence if you pass an entire sentence into porter.stem. So moving on to lemmatization, unlike stemming, it reduces inflected words properly in terms of the word that it reduces to is an actual word in the language, but it's very similar because it returns essentially the root word, but in this case, it makes sure that it's an actual word. So if you're working with a data set and you need the word to be an actual word in the language, it's important to use lemmatization instead of stemming. And the process is very similar. We import a lemmatizer from nltk.stem, and then you'll iterate through the data, iterate through each word in the data point, and take each word and stem it using wordnet underscore lemmatizer.lemmatize in the word, and then you'll rejoin the words. And the reason you go through this process is very similar to stemming because if you put in a sentence, it'll just return the sentence. So next we'll look at tokenization and removing stop words. So stop words are words like a, the, you, which don't add much external meaning to sentences, and it's important to remove them because when you're classifying, the words like a, the, you probably are in sentences for both classification categories. So for example, if you're trying to classify something as true or false, the words a, the, and you are going to be in sentences for both, and therefore by removing them, the classifier is able to reach the words that actually make an impact on the category more. And tokenization just breaks up the words and sentences to individual words. And so the process of removing stop words from a sentence is first you import stop words, and this just what you're importing is a list of stop words essentially, so a list of a, the, you, and whatnot. And then from tk.tokenize, you import word underscore tokenize, which is a function that tokenizes a sentence. So for example, if you have the sentence, this is a sample sentence, what you would do is you would assign stop underscore words to your language because stop words has a lot of different languages. And for example, if you're working with English like we are, you would just put in set stop words English. And word underscore tokenize, you pass in the sentence, and what word underscore tokens is set to now is just a list of the individual words. So be a list with this, comma, is, comma, a, comma, sample. And what filtered underscore sentence is set to is a list of all the words, but it removed all the words that were in stop words. So it essentially removes just all the stop words. And from there, what the code is doing is it's just rejoining the sentence by appending each word that was left over, and aka all the words that are not in the stop words. And that'll be a wrap to this first section of NLP.